Robots are making strides and can already see, feel, and act like humans. Countless engineers are slaving away to enhance their design, sensors, and abilities. Isn't it funny then that all robots share a common trait? They're absolutely useless. Where's the robot that cooks dinner and plays with the cat? When am I gonna have to stop going to the store for groceries? Where's my Rosie Jetson? We'll get to the bottom of this right here, right now. Let's get it. Robotics has come a long way from primitive controlled mechanisms to nimble humanoids. What's more, many people today seriously fear that robots may become too advanced and try to take over the world. And we don't even know how that will happen. Because in sci-fi, machines enslave mankind when they get smarter. And if robots surpass our intelligence, we won't even be able to understand what plans are hatched in those zeros and ones until they make it happen. Sort of like a robotic mishpucha. For now, however, the reality is that robots still need cues and guidance to do anything. It's kind of difficult to take over the world when you're still stumbling and falling. So let's focus on robot helpers for now, huh? The ones we've been promised for decades. The ones we dream of, who just clean the house, cook dinner, help us with chores, and keep us company. Like an advanced pet that you don't need to walk. Where are they? So check this out. We've spent a decade watching Boston Dynamics robots thinking they'll never leave the lab because it just doesn't have a brain. Yes, it's agile and can get from point A to B, skipping through obstacles, but every move has to be programmed. Okay, we got the new compact, flexible, and electric Atlas now. It knows how to navigate independently and move objects, fixing its own mistakes. It's not alone. Tesla, 1X, Figure, lots of companies are introducing their own product lines and developing at an unprecedented rate. There's a real race of humanoid robots learning new skills almost daily. They work hard, learn even more, and even begin to compete for jobs. Add artificial intelligence, and you got quite a concoction. There's hope that AI will finally solve robotics' biggest challenge: learning. Like opening doors or making a BLT just by watching us or practicing in VR. Sounds amazing, doesn't it? Here's the sour grapes. These robots aren't headed to your home just yet. They're still too expensive, too complicated, and dangerous. In an age of autonomous vehicles, space explorations, quantum computers, and scientific discoveries, why is it so hard to make a robot butler? To understand this, let's delve into how humanoids got started. Check out our previous video on the evolution of androids in YouTube cards. The most prominent example is Asimo, the most advanced humanoid robot a long time ago. The first prototype of the robot was actively developed by Honda engineers even earlier than that. It took several decades and tons of cash to turn it into a robot that can actually be put on a stage. And in 2011, the company finally unveiled Asimo. It danced, walked on uneven terrain, and ran in circles. It also climbed stairs, hopped on a leg, played soccer, and even shook hands with the president. However, reality turned out to be quite disappointing. Although the company remained silent on the matter for a long time, it finally had to admit that its every action had been thought out and programmed in advance. Any change in the environment could put the robot in a loop or cause embarrassing mishaps. You certainly won't want that in your kitchen. Unable to get ahead of the curve, Honda retired Asimo in 2022. Which begs the question, if it's that difficult, why make humanoids at all? Isn't Roomba enough? This little round piece of plastic first appeared on shelves more than 20 years ago, and now it roams millions of homes around the world. It can map out your floor plan, navigate around obstacles, overcome barriers, carpets, and even get along with pets. Eventually, it'll probably learn how to climb stairs too. In the meantime, it'll tirelessly get rid of dust, pick up litter, and mop your floors. For such a small, little nifty disc, that's quite a feat. After all, nothing is permanent in our homes. Furniture moving, children, animals, things falling. Wherever Roomba roams, there's traps waiting for it. No humanoid today can survive in these conditions. Our homes are like deadly obstacle courses for them. So why do we persist in trying to create human-like robots? It's simple. Initially, developers hoped to sell these things to warehouses or factories. Everything that could have been automated and streamlined with industrial robots or mobile platforms has already been done, leaving the last 30% of operations to humans. And this is where humanoid robots can show great results, because they can use the same tools and work in the same conditions as we do. In other words, owners of factories, warehouses, and ships simply don't need to change anything to get a machine like that started. You know what they say, if you can't beat them, join them. On the other hand, a number of companies are developing robots that completely copy human appearance to replace people in places such as reception desks, airports, and even classrooms. For example, a copy of Japanese robotics professor Hiroshi Ishiguro lectures students at Osaka University. But not everyone agrees. Many find attempts to accurately copy human faces just plain creepy. That's because when they look at these robots, they go straight to Uncanny Valley. That's an actual term coined in 1970 by another Japanese robotics professor, Masahiro Mori. The idea is that an industrial robot that is different from us does not evoke emotions. Humanoid robots, on the other hand, appeal to everyone. Tesla Optimus, for example, gathers crowds of fans, whether it's dancing or just standing behind glass. Cute robots that mimic human appearances also appeal to everyone, as we're biologically programmed to sympathize with our own kind. However, when a robot tries to blatantly copy a human, it evokes feelings ranging from mild discomfort to complete horror. All because they don't look, move, or sound anything like us. More like zombies, actually. Uncanny Valley is just a hypothesis, yet to be a provable fact, but does it work on you? Like, imagine seeing your robot in your hallway that's smiling, but its eyes are moving all weird. Double yikes or what? Let us know in the comments. It's because of this, Boston Dynamics made their head of their new Atlas robot look like a Pixar lamp, avoiding any associations with human noggins. Basically, it comes down to two things: hardware and software. For a robot to see the world around it, it needs cameras and 3D vision modules. That data is then processed by a computer that decides what the robot should do. Actuators and electric motors help it move, while the power comes from a battery so that the robot doesn't trip over its own wires. Devices that convert energy into physical movement, i.e. actuators, remain the weakest link for now. They're complex, expensive, bulky, and require radical upgrades. As a rule, there are at least 20 of them in a robot. What about the software? It's not enough for a robot to see a door, it has to figure out how to open that particular type of one. It has to be able to adapt, correct mistakes, and improvise like a human. This is still a huge challenge for even the most advanced AI algorithms. In the words of Crystal Method, there is hope. For now, however, engineers have to go the traditional route, collect vast amounts of data to train robots for each and every task. An AI model is then trained on that data and tested on a real robot. But practicing for one task at a time is a really slow process. The real breakthrough here will only happen if scientists invent a universal AI model for robots that allows all of their different shapes and designs to perform the same tasks. In the end, it all comes down to money, since both traditional methods of learning and universal AIs are really time-consuming and expensive. So what's the bottom line? Are the robots coming or what? We can't say for sure, but we can see three scenarios unfolding. The first one assumes that there will be no breakthroughs and robotics will continue to develop gradually as it does now. In that case, Roomba or Amazon's Astro is your best bet. It'll get around your house and take pictures of Fluffy, while the humanoids wander in warehouses and factories, slowly learning new tasks and gaining the trust of industrialists. Except for Atlas, since it's doing its own robot influencer thing on YouTube. Scenario number dos sees moderate development in robot hardware and software. New designs improve actuators, and artificial intelligence makes robot learning more practical. Robots move beyond lab demos and can finally perform useful tasks. However, these are not the general-purpose humanoids from the movies. These handybots are simple but nimble mobile handymen. They do your laundry and clean your kitchen. They can even take care of your pets. Better than nothing, right? Where are the humanoids in this case? Well, they're still working on the production floor or a conveyor belt. And future number 3. Let's imagine that we've made a breakthrough in both hardware and software. If robotic learning and efficiency surpass all expectations, then you and I, my friend, are going to be celebrating the future we've been all waiting for. The first generation of robotic assistants are ready to enter our homes. Even though they'll likely be super expensive, it'll be cheaper to lease one. Eventually, they'll become mundane, like good cars, convenient, occasionally requiring some attention and cost. Hey, at least they do the chores and take care of business, and most importantly, know how to make a good BLT. There's more, but we're out of time, so subscribe to the channel, like our videos, and check out our Instagram for more from the world of high tech.